Assalamu alaikum, welcome everybody to Practical Numerical Methods for Scientist and Engineer. We are still in Module 4, but we have new title. This is Rules of System of Nonlinear Equation. In the past previous 8 sections, it was all on linear equations. This time we'll start in nonlinear equation. So, in contrast to linear equation, nonlinear equations are curves, and their solution is not intersection of these curves. System of nonlinear equation can be solved by different methods, but here we will focus only on Newton-Raphson method and Excel solver method. Okay, so we'll use Newton. We'll describe how to use, and we will create MATLAB function, and then we will use Excel solver to use it. So keep with me. If you remember the Newton-Raphson for single equation, we used it before. It was for xn plus 1 equal xn minus f of x over derivative of x f of x. Now similarly, if we have a system of nonlinear equation, the system, the Newton-Raphson law will be similar to this one, but it will be little bit complicated. So here instead of x, we have x1 and x2, n plus 1, equal, instead of x1, I have 2 or more, but we will focus only on 2. We have x1, x2. Here we have f of x, so we have f1, f2, and they are the derivative, but here we have the derivative for x1 and x2, so it will be a matrix. So here it will be f1 over x1, and then the function 2 also on x1. Here we have f x1 over x2, and here we have f of x2 derivative of x2. So this will be my equation. Okay, now we can how we can use it. Okay, now if you are using your manual method to calculate, so it would be easily if we make some rearrangement. So we can say here, okay, we can move it here. Okay, so and in the same time we can move this here as well. Okay, so here it will be x1 over x1 and x2 minus x1 of x2 for n plus 1, so this will come as a minus, then this will multiplied by this matrix will be moved here, so it will be multiplied instead of division, and here the minus, the f1 and f2 will keep a minus. So here we have x and x. This is delta x. Okay, this is delta x1 and delta x2. So now the matrix will be the derivative of first equation for the x1 and the second equation for the x1, and here first equation for x2 and second equation for x2 times the delta x equal f1 f2. So if we can find the, if we can resolve it, we have two unknowns, two equations and two unknowns, so we can solve it by calculator or by any other method to find delta x and 1 and x2, and since we know the previous x, so we can calculate the second or the new x. So we can choose mode equation and choose this equation, this type of equation. Then we compute x1 and x2, and since we can then again, we know we said before, okay, we said okay, we said delta x1 is equal to x1 x2 n plus 1 and minus x1 x2 n. So then we can again, since we found this value, then x1 and x2 for n plus 1 equal the new, or the value that you got from calculator plus the old value x1 x2. Okay, so here let's take this example. So in this example, they want you to solve these two equations and give you variables for x1 initial variable as 1.5 and for x2 as 3.5. So first we can solve both equations. Okay, so first we have to write both equations. Okay, f1 will be, this will be f1 and this will be f2. Okay, remember that you should put it inside. Okay, okay, then we have to derivate the first equation for dx1. So when we derivate this one for x1, okay, it will be 2x1 plus x2. Okay, and of course this will be cancelled. Okay, so and second equation for x1, so this one will be 0 and this one will be 3 3x 3, yes, so this will be removed. Yes, it will be 3x2 squared. Yes, correct. Okay, and then for the okay, the first equation to derivate it for dx2, so it will be only x1. Okay, x1. And similarly, if we want to derivate the second equation for x2, so second equation for x2, this will be 1 and this will be 2 times 3 6, so it will be 6x1 x2. Yes, okay, now since we derivated the equation, then we can say again, we can put this one times delta x1 delta x2 equal to minus the f. So we put the equation. So this will be my matrix that I will use for with calculator. Okay, so then first iteration we have x1 equal 1.5 and x2 equal 3.5. So then just we can put, just plug in the data into the values so we can calculate. So then we have, by equation you can solve, it will be 5.54 and minus 0.66. So then we, since we already know the previous one, that 0.1, so it will be the new x n plus 1 will be 2.04 and 2.48. Okay, then we can continue to solve the equation. Okay, so these values will be used for the second iteration and so on. That's it for this tutorial. See you in the second tutorial. Thank you.